Hi, I am RK. Now we will see logistic regression using Excel. In linear regression, we fix the equation response variable y is equal to beta naught, that is intercept, plus beta 1 x1, that is coefficient for variable x1, plus beta 2 x2, that is coefficient for variable x2. Similarly, for all the variables, we are fixing the coefficients, plus we are adding a term residual, and our aim was to minimize the residues. So the summation of residuals, we are minimizing it, then we get the best fit. Now in logistic regression, we are going to have only two decisions, either yes or no. Yes, I will say 1, no, I will say 0. Therefore, I must get either 0 or 1 only for the expression result. So how do I get it? I use P, probability value, and then fix a cutoff also. Now the P value varies from 0 to 1, any value. Now what I will do is, I will fix a cutoff value 0.5. So if I get a probability value less than 0.5, this cutoff value, I say no. That means value is 0, y is equal to 0. If I get a probability value greater than 0.5, then I say yes, that is y is equal to 1. So I am having a p value which is varying from 0 to 1. I am converting that into 0 or 1 here. But this expression is going to give me a value minus infinity to plus infinity, all real values. How I am going to solve this? So I am defining a term odds is equal to beta naught plus beta 1 x1 plus beta 2 x2. The same expression I am calling this as odds now. Now what's happened? Odds I am defining here also is 1 by 1 minus p. So the range for this is 0 to infinity. How? When p is equal to 0, it is 1. Right? When p is equal to 0.999, then it is 1 by a small value which is higher value. Odds is equal to higher value. So 1 by a small value is equal to high value. So it goes up to infinity. So the range for odds is now 0 to infinity. So I can get any value from 0 to infinity, and then I can convert this into 0 or 1 using the same logic. Now the expression is going to give me a value from minus infinity to plus infinity. So what I do is, I call this expression as log of odds. So log of odds is equal to this expression. So log of a very small value is negative value. Log of high value is going to be high value. So the range is now minus infinity to plus infinity. So I fix this expression, get this value, find the odds. From the odds I find out this p value. From the p value I find this y value, 0 or 1. So I got the solution now. So odds is equal to exponential of this log odds, because exponential of log of odds is equal to odds, and that is this. Therefore I can find odds. Once I find the odds, I can find out p value, because p is equal to odds by 1 plus odds. When odds is defined 1 by 1 minus p, then p is defined as odds by 1 plus odds. Now we can get the matching pm from this p value here. So p is equal to p or 1 minus p. So observed value can be matched here. Now once I find this observed value matching, I get the p value for this expression, which is matching pm. I have to maximize this matching pm. How do I maximize this pm value? Because the total probability will be probability products, that is p1 into p2 into p3. But p1 is a very low value, say 0.9. So if I take 3 events, 0.9 into 0.9 into 0.9, it is close to 0 value. And if I have about 100 values, it will be 0.00000, which cannot be maximized even by computer, because there is a floating point limits there. Therefore what I do is, I use the relation for log, logarithm of the product I maximize. So how do I do it? Maximize log of pm means log of p1 plus log of p2 plus log of p3. It is only an addition. Therefore it is going to increase. That I can maximize using a solver. That is why we say that this is only by iterations we can solve, and we get this expression. Once I get this expression, I find the accuracy, precision and recall from the observed value and the predicted value. Then plot the scatter plots against cutoff values. Accuracy versus cutoff, precision versus cutoff, and recall versus cutoff. Right? Then I fix the cutoff value, optimize the cutoff from the scatter plots. Which one I want to maximize? which one I do not want to maximize. I will see from this and then I will optimize this. Normally we have to optimize all the three values, right? So at the cost of one, if I am increasing, and I may not go for it. So find the true positive and false positive values from this data. Now plot a line plot true positive versus false positive. And this is called ROC curve. Yes, this is called ROC curve. Validate the cutoff decision from the ROC curve. And that completes the logistic regression. Thank you very much for watching. We will do this logistic regression in Excel in the next session.